have another system of domestic pipes which looks like this, including the cold water and the hot water. Starting from the powerhouse where the cold water or the hot water is produced, that water goes up and leads to the collectors, and then they will be divided into branches, as many consumers as there are. So generally, this type of collector is totally different than the collector we saw in the office project. The water comes in from the powerhouse, and then there will be entering the branches to feed the consumers. Let's also take a look at this picture, another type of collectors. This pipe right here is getting the water from the powerhouse, and each of these branches is for feeding the consumers. Also here in this picture, we have another collector. As well as here in this picture, we have a collector which is installed on the wall. This is the box that's holding all of this together, and what's connected to it are insulated pipes. So what we're going to try to do now is we're going to place a collector like this one so we can see how it works. I'm going to go over to Revit, and the project that we have at hand here is for a school space, and this is for the lavatory of that school. First, I'm going to zoom in on here so you could see. This lower area down here is the powerhouse. From this powerhouse, two pipes would be going out. One is for the hot water and the other is for cold water, and they're both going to collectors. For each consumer in the area, there's an individual branch onto each of these collectors. For example, starting from the end of the line, this pipe over here is for the cold water, which goes all the way to here to the collector. Again, for this other line, this pipe is coming from the collector, as well as some other lines, and we have the same thing going on here too. There's one lavatory, there's another, and there's this one. And also each of these wash basins have some pipes coming from collectors. So this is what we are trying to draw now. In order to have the collector that is the best one for this project, I'm going to go over to the BIM Object website. After that, I'm going to go up to the Insert tab, then click Load Family. And then I'm going to go to Desktop, open the manifold folder. Then I'm going to select both of these families and open them. Now I have to wait for them to load into my project. And it also says that they are being upgraded from version 2015 to 2023. Now to place them, I'm going to go over to the Systems tab, and then I'm going to click on Plumbing Fixture. Here I can see the last thing I've inserted and loaded. And if I click to expand it, I can see 4 different fitting types. The diameters of all their endpoints are 16, but as you can see, one of them says 2.25 and the other says 2. So it seems like these two are different in thickness. As for the other end, we have 20 and 26. Now, if we go take a look at the plan, we can see that the starting end should be 1 inch, and each endpoint is 16. 1 inch means 25, so we're going to be using one of these 26s, especially the one that says 16 by 2, so we're going to select that one. Now, before I place this item, I'm going to have to give it a middle elevation. So I'm going to try to place this cold water collector at elevation 500 millimeters from the level, or 50 centimeters. Now I'm going to go over here and hit the space bar once, twice to rotate my item and put the starting end on the right side. Now before I click to place it, do you remember how the collectors looked in that picture? As you can see, they're on the wall in a protective box. So that means I'm going to have to place this collector in the wall. Click. Now to place the hot water collector, I have to go here and select it, 10-way hot water, the one that's similar to the cold water. So I'm going to select it, and I'm going to place this one at a lower elevation. So instead of 500, I'm going to put in 400 or 40 centimeters. Now I'm going to go over here and hit the space bar to rotate it, and then I'm going to make sure to maintain a distance between this one and the cold water collector. Then I'm going to click to place it. Now let's draw pipes for them. First, I'm going to click on the collector to select it. And do you see this connector icon? We're going to click on it and then go over here to the pipe types, then select Hex All Hex. Also, let's change the diameter to 16. And for the middle elevation, since we're going to be placing these pipes in the ground, we're going to be needing a negative elevation from the FFL. So for example, I'm going to give it -30 or -30 millimeters below the FFL. Now I'm going to move forward and click, and then I'm going to go to the left, click again, and then let's go a little bit further, make a click, and click again at this mixer, then press escape. Then I'm going to add a branch over here, click, click, and this pipe would be leading to the flush tank. This time I'm going to work with the hot water collector, and once again I'm going to click on this create pipe icon, and this time I'm going to change the elevations. In the previous one I drew at -30, so let's make this one -50. Then I'm going to go over here and click, then move to the left and click again. And finally, I'm going to come down here to the mixer, click, then press escape. Now let's go on to the next stall. I'm going to start from the cold water collector, then go over here, click on create pipe, and don't forget the elevation -30 again. And then I'm going to go up here, make a click, and then move to the left, click again, and click down here. Now press escape, and then draw this branch for the flush tank, then press escape again. This time, let's go to the hot water, click on the collector, and then hit create pipe. Then I'm going to go up here for the middle elevation, and I'm going to type in -50. And then starting from here, I'm going to go up and make a click here. Then I'm going to move to the left and make the second click here. Then I'm going to go down to the mixer, click, then press escape. So we're going to have to draw these pipes for each stall in order. What about the pipes on the opposite side? We're going to do the same thing for them as well. For example, select the collector, hit create pipe, make the middle elevation -30, and this time I'm going to draw this way. I'm going to go down and click, and then we're going to continue towards the consumer that needs it. We would have to draw the hot water pipes the same way. But for now, I'm going to go over here and hit the tab key 1, 2, 3, 4 times, then click, hold the control key, then go on the hot water pipes, hit the tab key 1, 2, 3 times, and click. Then click on selection box so we can take a look at them in 3D. Here we have the hot and cold water pipes. I'm going to rotate it so we can see from the front too. And here's how we've drawn our collectors. If we go back to that picture, we can see the same thing going on. Hot and cold water pipes are coming out of the collectors. They're going inside the ground and heading to the lavatories. As for connecting these pipes to the items and the fixtures in the restroom, we've discussed all of that before, and here we just had the collectors. Also, to draw the pipes that are coming from the powerhouse, first I'm going to go over here and click on the cold water collector, then hit create pipe, and draw a pipe a little bit further, and now I'm going to have to make it go in the ground at elevation -30, and then draw a little bit further. Actually, I'm going to have to draw more so that there's enough space for an elbow. There we go. And since we don't have the rest of the powerhouse, we can stop here. But first, let's go take a look in 3D. Here's the pipe. We're going to select it and move it to the right in order to save more space. We're about to model some radiant heating pipes. So first, we're going to be taking a look at some plans so we can figure out what is going on. First, I'm going to go over to the projects folder. And after that, radiant heating project. Here we have 3 floors available. For example, I'm just going to select the first one and open it so we can check out its plan. Now what we have here is a 2-floor villa space, which if we look closer in its first floor, we can see this master bedroom right here. Now if we zoom in a little bit more, just like how we had collectors for our domestic pipes, we have some collectors here as well. One for supply and one for return. This red line right here is connected to one of those collectors. The pipe is coming this way, and then it continues along this direction. And then as you can see, it keeps turning and changing directions, and eventually it reaches the return collector. Same thing as this blue zone as well. The pipes are going all the way around and then back to the collector. So for this room, we have one cold collector and a hot collector. Also, each of them has 2 ports. Also, taking a look at this space, we can zoom in and here we can find the collector. There are also red and green lines. Just like the previous ones, these also keep turning around the level, then back to their collectors. And also, if we take a look up here at this bedroom, we can see that there's a line that's coming from the collector right here that turns around in the room and goes back to the collector. So this is what we're going to model. But before that, we're going to take a look at some pictures so we can understand this better. We have radiant heating pipes here, which look exactly like what we just discussed. There are some holders holding them into the ground, and the pipes are installed like so, and then the flooring would be done over them. Let's view the next image. This is from another angle. And in this one, if you take a look here at the left, we have this collector. We can see it in the next picture. These pipes are coming out of the collector, then cover the zones they're related to, and then come back to the collector. So let's check out this next one. Here are the supply and return collectors to which all these pipes are connected. We are about to model this. So I'm going to go over to Revit. Then I'm going to select my project, going into the Radiant Heating project folder, and then I'm going to select Mechanical Radiant and open it. Remember that all of the settings in this project have already been adjusted, and all you have to do is go into the right floor plan, link your plan into that one, and then adjust the settings for drawing your pipes. Now I'm going to go over here to the project browser window under Discipline Radiant Heating, and then I'm going to open my first floor plan. I'm going to link my plan into here, but first I'm going to have to check what the unit of that plan is. So I'm going to go over here and, for example, measure the width of a column. I'm going to click here and here, then somewhere blank. Now we're going to check the number, and here's what we've got, 41 something. So I'll figure that this is probably 41 centimeters, but also I'm going to double check in dimension style. Let's click on modify. And then in the primary units, I can see that the scale factor is 1. All right, so I'm going to link this plan into my project with the unit centimeter. So I'm going to Revit, Insert tab, then click Link CAD, and then I'm going to select my plan. Check Current View Only, Import Unit Centimeter, Positioning Center to Center, then click Open. Now we have to wait for the plan to load. Now, in order to place the plan in the right position, we're going to be using a line AL, grid A with A, and on this side, 8 with 8. Okay, now, if we take an overall look at the plan, it seems like the imported units are not compatible with our project. That's probably because the plan was not scaled, so we're going to go scale it. First, I'm going to select the plan. Let's make it selectable. Then select it, and then go up to the Modify tab, find the scale command and click on it. I'm going to want to scale this plan right here graphically because I don't have any scale factor numbers to scale it with. So then I'm going to zoom in on here, and then I'm going to say that I want the distance between A and B from the plan to be the same as the distance here. The reference stays where it is, so we're going to click on here to make it the same distance as the other. Now we've scaled the plan at that axis, and now for the horizontal axis, it's just enough that we align them AL, then align grid 8 with this grid 8, and that way all the other grids have fallen into the right place. Now I'm going to go over here and I want to start drawing my radiant heating pipes from the pipe type pixel or 5 layer. Just the same thing we used for the domestic pipes. So first I'm going to have to open its template and then transfer its information into my project here. I'm going to click open, then go to where I've downloaded my template, which would be this folder. Select the template and open it. And now I have to wait for it to upgrade from version 2015 to 2023. Once the template opens, I'm going to go back to my own project, then to the Manage tab, and then click on Transfer Project Standards. Here it says Copy From, where we need to enter the plan we're copying from, and here I can also see the plans that I've linked into my project. So I'm going to open the drawer, then select this template. Now here in the list, I have to specify what I need to copy, but first I'm going to hit Check None to uncheck and deselect all of them. Now I'm going to scroll down to find pipe types and check it, and then click OK. You might also come across this message in regards to the materials that are being transferred, saying that some of them already exist. So just click OK. And then another window could pop up also about the materials. And then here I'm going to click New Only so that only the new ones would be transferred. Now to begin drawing, I'm going to go over to the Systems tab, then click on the Pipe command, and then I'm going to go over to the Properties window to select my fitting type, which would be Vossier Pexel Standard. Now for the system type, I'm going to go over to the Project Browser window, open the Families, and then Piping Systems. And now here I could just duplicate this hydronic supply system type. So I could use the duplicated one as the system type for these radiant heating pipes. So I'm going to right click on it and click duplicate. Then I'm going to rename this duplicated one to radiant heating supply. Then press enter again. Then in front of graphic overrides, click edit and select a color for these pipes, for example, orange. Click OK, OK, and OK. Now go to Systems, Pipe Command, and now here we've already selected Pexel. And now for the system type, we're going to select Radiant Heating Supply. As for the diameter, we're going to put in 20 millimeters or 3/4 of an inch. And for the middle elevation, we're going to want it to be negative from the FFL. In other words, we want to place the pipe into the ground. So I'm going to go over here and enter -100 or 10 centimeters below the finished floor. Now I'm going to go over here and start drawing. Make the first click, go a little further, make the second click, then according to the plan, come all the way down here, make the next click, then move to the right, make the fourth click, up here the fifth click. But if I try to move forward from here, the radius is too small to get an elbow. So I have to go further up and then move to the right. I'm going to press escape and then set the display on shaded so we can see better. And now we're going to try to see how low this elbow can go. We're going to move it lower. This is as far as it goes, and even though this is not exactly how the plan intended, that's all right. We're going to continue, right-click, draw pipe, then move forward to here, then move down, click, and again, it doesn't go to the right, so we have to make this longer, and now we can turn to the right. We're going to go all the way here and click, go up and click again, then move to the left and click here. Now I'm going to press escape, then try to move up this pipe as far as it goes. So let's go on. Right click and draw pipe. And then I'm going to zoom in on here, click at this point, then move up and to the right. But the radius is too short, so we're going to make this one a little longer. Then we're going to turn to the right, click, go upwards, move to the left, and let's pause here. Let's align the pipes AL, this one with this line. But then we get an error in regards to these two elbows. Do you see how they are going into one another? So that alignment can happen here, but we're going to do it anyway, and we're going to make it delete the extra fittings. But then if we try to align these, do you see that error again? The thing is that this radius for a pipe of the pixel type with diameter 20 is in reality way bigger than what we can see in the plan here. So let's hit cancel and then measure the plan. I'm going to go to the Annotate tab and then click on Radial. Then I'm going to measure the radius of this drawing in the plan. So it seems like the radius here is 75, whereas the radius of this elbow that we've drawn, if we go take a look at it in the Properties window, and we can find its number right in front of this parameter. The parameters are in Italian since the brand we're using is Italian. So it says 3.15 inches. I'll open my calculator and multiply 3.15 by 25.4, then we get 80.01, and we'll round it to 80. So on one hand, the radius of our elbow is larger than the radius of the drawing, and on the other hand, the radius is not editable here. We'll even go to Edit Type, and once again, here we don't find any parameters in regards to the radius, so we could change it. So what I'm going to do is I'm going to go to the family space and make some changes to the elbow family itself. So first, I'm going to select the elbow, and then I'm going to click Edit Family so I can go in the family space. And then here, I'm going to open the Family Types window, and then I'm going to look for the radius parameter, which would be this one. By taking a look, I can notice that there's a formula written for it. I'm going to also expand the window so we can see all of it. There we go. Our formula starts with the word if, so it's a conditional one. And then a little bit further, it says size lookup. There's actually this concept or term in regards to modeling fittings called a lookup table. A lookup table is in fact an Excel file which has been organized specifically based on some things, and then that table would be introduced to Revit, and then we could adjust in a way that we can make the radius follow the rules that are mentioned in that lookup table. That way the parameter in Revit would not be allowed to follow or enter any other numbers than what has been mentioned in that table. You already know that your pipes could have so many different sizes and diameters, but not all of them have been produced. So based on all of that, this formula basically says that it needs to follow the rules that are mentioned in the table called TDR. And also up here, we can see this parameter called TDR with this value in front of it. Let me expand further so you can see it too. Now you see it says Valsier, Pexel, Mixel, Pipe, Bend. We're going to check it out later. So from this TDR lookup table, the mechanical parameters should be followed. And now these mechanical parameters should be used by what value? It should be the same as the number or primary value that's been given to the OD. So that means if we have a value for the OD, the mechanical parameters should also follow that one. But remember, if you haven't given any value to your OD here in this list, you could make up for it by giving it the number 1000. Let's expand the window a little bit more. This formula is conditional and includes some other items. Then it also says from the lookup TDR, the manual parameters should be used by the same value that was primarily given to the OD. If there were no values, you could put 1000. And then it also says use the mechanical parameter, same as the primary value of the OD, if not 1000. But now we got to figure out what this if means. What is the condition here? Generally, we could say that this if means that if the condition that is given is true, Revit would apply the first condition, but if that condition was false, then the second condition would be applied. Now we gotta see what this mechanical bending means. So let's take a look over here and find mechanical bending. You see it is checked. So if the mechanical bending was on, then these mechanical parameters would be used. But on the other hand, if it were unchecked, then the second condition would be applied. So if the condition is true, then the first one applies, and if it's false, then the second one does. So that's it about the if part. But there's also another condition. If the OD is smaller than 40 millimeters, then the first if would be applied, and if not, the second if would. So this is just a bunch of complex conditions, but this is not my point right now. What I'm mostly focused on is this lookup table. Like I said, the lookup table is an Excel file in which some parameters are defined, and we could make Revit read the parameters from that Excel file. So now let's go see where we can find this TDR Excel file with this value. At the bottom right of the window, we can see this button, Manage Lookup Tables, so we're going to click on it. And as you can see, once we open the window, we can see the same name here, Valsier, Pexel, Mixel, Pipe, Bend. So first I'm going to export it. Export it where? I'm just going to put it in the desktop. Click Save, Cancel, Cancel. And now I'm going to head over to my desktop so I can open the Excel file. So like I said, we have some parameters over here with these specific values. Let me expand the columns. And for example, we have this parameter OD here from the type length, and in the unit millimeters is 14. We also have this manual parameter from the type length in millimeters. We also have this internal spring parameter, length by millimeter, as well as external and mechanical. So that's all the parameters we have here. Now, what's the size we were dealing with? It was 20. So its manual parameter would be 100, and the internal spring, external spring, and its mechanical spring are all 80. Now, the parameter related to the radius is following the same thing as this mechanical. So I could just use this value for my pipe, which is 20, or I could use a smaller number. When I measured in the plan, I got 75, but since Revit doesn't allow us connect a fitting to another one, We're just going to be using a smaller radius so that then we would be able to put a small pipe in between the two fittings. So I'm going to change this 80 to 70. In the plan, I had 75, but I'm going to change this to 70. Then I'm going to save it by Control S. Then I'm going to close it and then go back to read it. I'm going to open the Family Types window again. Then I'm going to click Manage Lookup Tables. Then I'm going to delete this file, hit Delete. And then we get a message saying that this lookup table is the reference for some parameters. Are you sure about this? Delete anyway. Now we're going to import again, then select this edited Excel file, then open it. Then click OK. And now the reference for some of the parameters is this changed file. Click OK. And now we're going to load it into project. Load into which project? This mechanical radiant heating. Click OK. Then overwrite. And now do you notice how the radius of this elbow got smaller? If I click on it now, I can see its radius is now 2.76 inches. Let's multiply to double check. 2.76 multiplied by 25.4 equals 70 point something, and we're going to round it to 70. Now we can very easily align our drawing with the plan. Let's delete this number, then hit AL, click, click. There's also this very small space between them. Like I said, we are not allowed to connect two fittings in Revit. So that's why I chose to put a smaller radius than the actual one, so we can have this part between them. Now I'm going to select this elbow and move it to the left so that it's exactly aligned with the plan. Now to continue, we're going to right-click and draw pipe. Then I'm going to go all the way to the end of the line. Click here, go up and click again. And let's also make it a little longer. And now we can easily turn to the right because we're going to be getting the elbow. I'm going to go to here, click, then press Escape. Now let's align our drawing. We're going to make it more precise. I'm going to take this and move it up. And then hit AL to align this with this. Now before I continue drawing the rest of it, as you can see, most of them are very similar. So instead of drawing the rest of the pipes one by one, I could just use the Array command or just copy them. I'm going to select this pipe, hold the Control key, select this elbow, select this pipe, and this elbow, this pipe as well. And then here, select this elbow and this pipe. Now I'm going to copy them, click copy, or I could just use the Array command. So now I'm going to click on the axis of this pipe and take a copy and put it right over here. I want to put another one up here, but first make sure multiple and constraint are checked. Let's put another here, then press Escape. And now let's connect these pipes by using trim TR, then connect this pipe to this one. But then we get an error saying that there was not enough room to place the required fittings. So that means the radius would be a little too big for here. So once again, I'm going to figure that because of the radius of this elbow and the short length of this pipe over here, this connection can't happen so easily. So once again, the best option would be changing the radius of this whole family. Therefore, we're going to open that Excel file again. And then here we're going to change this number 70 to something even smaller. For example, 65, Control S to save it. Now let's head back to read it. Go over here to the family space, then click on Family Types, and then Manage Lookup Tables, and then delete this file, delete anyway. And then we're going to re-import the table, select this new Excel file, open, then click OK and OK. Now we're going to load this into project. In mechanical radiant heating, click OK and overwrite it. Now that our radius got smaller, we're going to use trim again, TR, connect this to this. Now they can be connected easily. Now we're going to go up here and we have to draw the rest of the path. So right click and draw pipe, go a little further, and then move upwards, click here. And then I'm going to turn all the way to the left, click, and then I'm going to move upwards, click again, then turn to the right and click here. And now the next thing we should do is place the connector so we could connect these pipes to them.